Welcome to Breadboarding. In this series we're building a 386 based breadboard PC, and in the previous video we wired up the various data bus buffers and latches and the address bus buffers and latches. Now during this video I was talking about just putting some DuPont rainbow cables between various points on the board here. And if I just show you where these connections were going to need to go. So we had the 32-bit processor data bus, and we needed to connect this all the way up to the 32-bit memory board up here, but also each of these chips here needed to have each side connected to here. Then there was also the 16-bit data bus that goes off to the ISA bus, where most of the rest of the computer talks to the CPU. And for this we needed to connect the most significant bytes together, the least significant bytes together, and the least significant byte here also needed to go down to two chips here. Then we also need to then feed that all the way off to the rest of the computer over here. Now on the address bus side of things, we've got the processor address bus coming into these buffers here, and that needs to also go off to the 32-bit memory card. And also these two buffers here also then need to have this side connected over to here. So there are going to be quite a lot of connections going on here. So if you just have a quick look at what this would look like. So what I've done here is I've used these DuPont rainbow cables. So these basically are just standard sort of DuPont cables. So they come like this, normally with a single connector at the end. This one's male to male. And then generally what I've done in previous series, we then use some of these sort of 8-way crimp housings. And if you basically take off all the individual connectors, replace them with one of those, then you end up with DuPont cables a bit like this. So this is one with male to male and is about 20 centimeters long. This is a male to female and is about 10 centimeters long, appropriate for shorter hops. So these cables have actually worked very well for me in the past, but in the Breadboard PC series, the two of them, and we're only really dealing with 8 bits of data, so we'd only be having to worry about these sort of couple down the end here. But because we're dealing with 32 bits of data, then we've got a lot more of these cables. So what I've been looking at doing is seeing, is there a better way of actually doing this? So this is video 12 in the 386 Breadboard PC series, and in this video I'm going to be looking at producing wire wrap connectors for the 32-bit data bus. So if you have a look at the KiCad diagram, so this is the KiCad diagram we're working from. I was originally planning to do a wiring up of all of our CPU control logic and state machine down the bottom here, but I kind of got diverted into looking at how we wire up all of our buses here. It's partly because I've started to do the schematic for the 32-bit memory card and also for the 16-bit BIOS EPROMs over here. And as I've been doing that, I'm becoming sort of aware of some of the complexities of actually connecting all these things. So you can see that this is the processor data bus that I showed you on the earlier slide, and you can see that this all needs to connect up to here as well. And we've also got the SD0 to SD15, so this will end up being the ISA bus, going off the ISA bus, and this is also going to be connected to most of the other peripherals, things like the video card, the timers, the DMA controllers, all those sorts of things. So I came across this website, Runtime Micro, put together by Lee. So I've had a few email exchanges with Lee, and what he's actually done is looked at making slightly more permanent solderless breadboard solutions. And so the number of examples here where he's using these sort of 0.1 inch pins to make slightly more permanent connectors. So this is an example here where he's actually using wire wrap to wire these things together. And in fact, in the site here, there's a whole section on making these custom cables. And the only bit that I've really diverted from what Lee's done here is that I found that putting the sort of sticky tape, so this is where you put sticky tape around to protect this, I found that because I was needing to make the odd changes and sometimes the odd wire would pull off and I couldn't really see it very easily. And so what I'm actually going to do is a slightly different approach to using this sticky tape in adopting this technique. But there's well worth having a look at this site. I'll include the URL in the description below. So feel free to go off and have a look at that. I'm sure Lee will appreciate any feedback. So if we go back to our DuPont cables here, so I'll just pull these out for the moment. So these are the ones we can have going off to the 32-bit data bus. Then we need to tie the upper bytes for the 16-bit data bus together. And then we've got the lower. This goes off to the 8 bits that go off to the peripheral X bus. And then these are the cables I was talking about that I didn't put them in the last video because they'd be hiding what's going on underneath here. Okay, so in order to make these, there's various types of pin headers. So this is the standard sort of pin header. I think these are about 12mm long. The local supplier I use also does 15mm pin headers. And also there are these 19mm ones. So the 19mm ones are the ones I'm going to be using for making these. And in fact, here's an example of one of the ones I've made already. You can see very similar to what Lee has been doing. The only difference really being is that I've made this sort of cover for it. And this is actually made of some sort of transparent. This is actually used for making photocopied sort of overhead projector transparencies. I think I had a pack of this from a very long time ago. Basically, if you just cut them into strips, and what I've done is I've made holes in just make holes in this, and then just score the sides here so it bends up a little bit better, and that just makes quite a neat little holder. When I was trying the tape method, so this is the double-sided sticky tape, sometimes I didn't quite get it sticking to the doubled up connector there. So in general, rather than using a single width of this, you tend to use 2 strips. So you double up on that, so it makes it a little bit chunkier to get things on. So in fact, I've made a number of these, and so I'm going to be trying these out to start with. So if you just put these in here, we can see the advantage of these, and the reason why I'm using this sort of plastic here is that this bit here is very, very thin, and so there's not really a lot of space. And what I've done is I'm continuing to use the purple is for pin 0 or pin 1, which is what all these DuPont cables I used, and I tend to start them all with purple on pin 1 or pin 0, and that's because the logic analyzer I use the same color coding, so it just makes it easier. So you can see here that if we plug these in here, that we can route the cables around, but they actually don't take nearly as much space. So I'm just going to do the other 3 I've got here. Now, when I've actually finished this, what you can do is actually stick the those 2 flaps together. You stick those together. I was going to use probably a Dymo label, so that's a label printer to put the data bus. So this will be the byte 0, D0 to D7, for example. I was going to put that on there. But for the moment, I may want to add some more wires on here. And what you use for doing this, so this is multicolour wire wrapping wire that we've got. So I covered this in some of the earlier videos when we were making this breadboard adapter here. And this wire wrapping tool allows you to carefully wrap that wire when it's stretched appropriately onto each of the pins there. Now what I was planning to do here is I should actually be able to wire up another layer of wire wrap here. These pins are probably long enough for having 2 or even 3 wraps on them. And so what you should be able to do is to take the wire off of these 4 plugs here and actually feed those over to similar plugs actually on the 32-bit memory board, which is going to be up the top here. Now I also do need to wire in the 2 most significant bytes and least significant bytes here. So I'll kind of have a go at recording, making one of those. I will speed it up because it does take half an hour or so just to show you what things are. So we're going to start with using the 19mm header strips. So I tend to use these shorter ones, which I've got lots of, and I tend to pull the pins out just to create an extra plastic blank there, and then we stick it onto here. So I'll go through and make those, and I'll speed it all up and be able to plug in our connector between here and here, or here and here. Okay, to start with, so I've got two of the 19mm connectors. I've just cut these into 2 blocks of 8, and this is the standard sort of pitch thing, and all I'm going to do is to pull the pins out so I can get 8 blank strips here to augment that. So I'm just going to do that. I got that. We can just now marry up that to the 8-way. Just press those on there. Trim off the other bit. You can just push that on the bit of board. At the moment, I'll just do this other one. Okay, so now we've kind of got a doubled up connector there. Now what we do need to do is to adjust the lengths of the pins, so you can actually push these through, and it just requires sort of pushing on an edge or something like that. I tend to do it on the edge of the board here. So you need to adjust it so we get the appropriate length for going into the breadboard. So generally about 6 or 7mm, and need to leave enough here on the top so that we have enough to do the wire wrapping. So then just go through and do the rest of those pins. Sometimes you might just need to push the pins individually to get them just to be the same length. That's reasonable. So now we can just stick that in. So in Lee's diagrams, and I think there's also a video I seem to remember seeing, then I've just made 2 markings where I've measured out the gap between the 2. So we just need to do this one as well. Okay, so now we've got the 2 8-way connectors in there. So now we need to take the kind of wire here. So this is special wire wrapping wire. So for the wire wrapping tool, it has, this is 30 gauge wire, and this one's quite neat, comes from Amazon, and it's actually got the 8 colours, very similar. The 8 colours are almost the same as these ones, so I'm able to use the same colour coding that I use for the DuPont cables. It's a little bit fiddly getting the wire off here. Now we need to leave enough for the end, so it needs to be enough to have at least 1 inch for the longest wire. So rather than cutting the wires individually, I tend to cut them all in one go. It does mean wasting a little bit of wire, but at least means that way I end up with similar amounts of wire all the time. So just going to cut this off. Once or twice I have ended up cutting things a bit too short, so I tend to prefer to err on the side of caution there. In general, I think what Lee has recommended is probably wiring pin 1 to pin 1, pin 8 to pin 8. But in this particular case, because where we're fitting it on the board, I'm actually going to wire pin 1 to pin 1, because we're actually going to be wiring effectively D0 to D7, D0 to D7, for example. So I'm going to be wiring that one to that one. So we're going to start actually, if we say assume pin 0, pin 1 is down here, we're going to start with purple. And in order to do this, then what I've got here is a little, this thing here just is about the right length. Or in our wire wrap tool, you'll see there is a slot down here, and we want to cut the wire so it's actually most of the length of that slot. And this bit here just means if I measure off here, then this should hopefully give me something almost the right length. So there is a stripper built into the wire wrap tool. So that strips that off. And then we just need to measure here. Now again, this bit is a little bit trial and error. What I've found is it's generally better to have a little bit over. So we're going from pin 1 there to pin 1. And I want to allow for a little bit extra. So, and then we'll just chop off the bit that we don't need. Okay, so that's a bit of wire. So we're just going to wire this from here to here. Now to do this, I have done this on some of the earlier videos where I was doing the breadboard adapter for the CPU. It's a little bit fiddly, but there is a very tiny hole at the top of the tool that goes through to the slot. In fact, for some reason, the wire wrapping of this first one stopped halfway through. So I'll just do it with, so I've cut the blue one, which is the next one for the second pin along there. We'll just feed it in to the very tiny hole at the end there. Put it over the pin. Twist gently. Don't press down too hard. Okay, so that has done it okay. Put in the hole again. The second pin. And just twist 2 times. Okay, so that's done. So first 2 are done there. I'll just go off and do all the other ones I've got over here. We'll come back and then we'll show how to finish it off. Okay, so those are all wired up now, and what Lee then recommends is then taking this and then perhaps giving it a couple of twists, just so that the wires are a little bit tighter together. Okay, now what I need to do is to bind a bit of black wire around there just to tie them together a little bit. Okay, so we'll now just trim that off. So there we have our connector. Now all we need to do now is to use our sort of plastic cradles for those. So here's a relatively thin strip, and the way how I've actually found the best way to do this is cut it into about a 2-inch wide strip. These pins are literally the same pins, but I did sharpen the end of them on a grinding stone, so they are a little bit sharper, and it's actually possible to sort of punch through the holes on those. So I've made the holes in there. In fact, I've found it's pretty easy also then just to widen the holes a little bit. The sharp pointy tool. Now the only other thing I need to do is to score each side with a sharp knife. See, not too hard, or it will cut through it. That just means that it's more likely to bend. And then we'll just cut. I'll just cut the other side off. So now it means that if we want to pull this out, it comes out a lot easier, and there's no danger when I tried it with my sticky sided, double-sided tape. When I tried that, sometimes it would pull off. It also means that you can see, for example, which colours where, and also if anything's come loose, then you can also see that. Now, as it stands at the moment, what I'm going to do is to leave these free like that, and then it means I can actually, perhaps if I needed to wire in another connector on somewhere else, I could actually put the other wire on here and lead it off to another connector. So that's what I'm going to do. Just going to make another one of those, put it on there, and then we'll put it in the board. Okay, so just going to put these. So this is going to go from D0 to D7 up to SD0 to SD7. Raise the cable a little. So you can see from the top there, compared to having lots of these DuPont cables over the place, then I think this is going to give a much easier to see layout. And obviously once we actually tape these things up and put labels on them, they'll become quite clear what's going on. And the other advantage here is that when I need to wire in the chips down here, I can actually just put some more wire wrap on this lower one down to the bottom here. And in fact, for these ones here, I will actually put extra wire wrap on there, and they can go all the way up to the top here where the 32-bit memory board will be. So thanks to Lee for providing that sort of advice on how to go about doing this. So the only difference really is, rather than using this sort of double-sided tape, then I'm using this sort of overhead projector transparency stuff. So I think nowadays you can get it as either inkjet or laser printerable clear film. And I think if you get that stuff, certainly the laser printer stuff should be a similar consistency. This was okay to go around a hot photocopier roller. So I think this is going to be a much better way of doing things. And when we've actually got lots of cables going around here, this will make it very much neater. So thanks for watching. If you don't want to miss out on future videos, then please hit subscribe. If you'd like to leave comments below, I do try and get back to you within a day or so. If you could hit like if you found the content interesting and useful, just helps to make the videos available to more people. Thanks for watching.